So guys, I've circled off that 2 that's multiplying the function out in front. And that's because it changes the vertical distance from the center line up and the center line down in a sine or cosine function is called the amplitude. And so it's twice as tall. Normally it goes from -1 to 1. Now it's going to go from -2 to +2. Again, that's above the center line. Next thing is the period. And the period is affected by whatever coefficient there is next to x. So we take our usual period, 2 pi, and I'm going to write this out, but really there's no need to show this. If you're dividing any number by 1, it just stays the same, right? So the period for this function is still 2 pi. The phase shift is the same as a horizontal shift, and that's determined by 2 things. The constant that's being added or subtracted inside the function, and also any coefficient on x. And so because we're subtracting, that moves this function to the right. And I'm going to put 2 pi over 3, and I'm writing this only because some problems have numbers other than 1 out here. So it's 2 pi over 3 over 1, which of course we know means it's just plain old 2 pi over 3. So it's moved 2 pi over 3 to the right. I'm just going to write that out. Our vertical shift, that's determined by anything being added or subtracted outside, right? So that 4 means it's shifted up 4 units. And lastly, reflections. This 2 is positive, so there is no vertical reflection. If that was a negative number, then we would say it was reflected vertically. So the next thing for us to do, and I always recommend this anytime you're sketching the graph of a trig function, is to move your x and y axis the way they're supposed to be. Okay, so you're kind of shifting or transforming, translating your origin. For these trig functions, definitely draw your x-axis first. So I'm going to put 2 pi over 3 here. And what that is that's technically my y-axis that I've shifted, right? Instead of the cosine function starting at 0, it's going to start at 2 pi over 3. We're still going to stretch it out and divide it up into 4 equal pieces. You see this? So I'm just kind of putting the tick marks, and now it's a matter of figuring out how far apart they are. So I'm going to take, let's see if I can use some highlighters here. This is similar to what we did in class. I'm going to take my starting point, and to find the end, I'm going to add the period. So I'm taking 2 pi over 3, and I'm adding 2 pi. Again, I'm just taking that from the period, right? So I'm adding the 2 pi to it. So I'm going like this. Hey, look, add 2 pi. Of course, you all know you can't add unless there's common denominators. So just a little bit of arithmetic here. I get 2 pi over 3 plus 6 pi over 3, which is, of course, 8 pi over 3. So that's what I label this one, 8 pi over 3. I'm just going to, again, use a highlighter here to help communicate what's happening. There's my 8 pi over 3. And if I want to find this middle spot, and I'll color that one in green. So I want to find the green. You guys all know how to find the middle. You know how to find an average. If you take the yellow, you add it to the red, or the pink, I should say, and then divide by 2, we should get the green, right? So what I'm going to do is write it out. Instead of dividing by 2, I'm going to multiply by 1/2. I think you all know that multiplying by 1/2 is the same as dividing by 2. And so if I do this, I can find that little spot right in the middle. So I'm doing 2 pi over 3 plus 8 pi over 3 times 1/2. 2 and 8 is 10. 10 divided by 2 is 5. So I've got 5 pi over 3. Now if I want to find the blue spot, I'll put this, make this one blue right here. I mean, hopefully you're seeing the pattern, right? We should be able to take yellow, add green, divide by 2, and get blue. So 2 pi over 3 plus 5 pi over 3. So 2 plus 5 is 7. Can't take half of 7. Gives me a decimal. So I'm going to double the bottom instead. So I get 7 pi over 6. And I'm going to do a similar thing to get this one. 5 and 8 is 13. Doesn't cleanly divide by 2, so I'm going to double the bottom. There we go. Again, I didn't show the work for this one, but it's the same process as I did here. Once I have that stuff, now it's time to draw my y-axis. So if I've got 2 pi over 3, 5 pi over 3, that's this whole thing. If I want to put my y-axis, it's got to be somewhere over here. Now the exact location, we're not too worried about it, but we do know that it's been shifted to the right. Now the next piece is to show that it's been shifted up 4. 1, 2, 3, 4, 5, 6. So I'll put 5 there, and I'm going to put a dotted line here because it's been shifted up 4. What that does is give me my center line. Right, so when I'm sketching my graph of whatever function this is, I've got my center line. I can do, it's hard to see these colors. There's a dotted blue line, so that's giving me my amplitude of 2 up and then 2 down from the center line. And I've got a really nice clear guide to draw the actual function. So the last piece is to say, hey, look, it's cosine. Cosine starts high. And remember, there's no reflection. So start high, down, keep going down. You've hit the bottom, you go back up, and you end high. And there it is. So there's our cosine. We just have to connect the dots in a smooth way. Right? So that's what happens when you take that cosine, you double it, and then inside there's some stuff happening. Again, go past what looks like the endpoints, draw a little arrow at the end to show that you know it keeps going, and there you have it.